Hey wise ML people, this is ML Wiser and today I am starting a new series called Practical NLP for All. My goal here is to teach everyone about the fundamentals of NLP in a more practical way to help anyone kickstart their journey in this field. The first video in this series will cover basic text pre-processing in NLP and we will also look at a simple but effective feature extraction framework for text. So without any further ado, let's jump into this. So the core resource of the NLP is text. Therefore, let us think for a moment about what exactly we mean by it. So you can think of a text as a sequence. At a low level, it can be a sequence of characters or words, and at a high level, you can imagine it as a sequence of phrases like "it was nice," which is a phrase, or named entities such as Central Zoo, the museum, etc. In this video, we will consider text as a sequence of words, and a word is basically a meaningful sequence of characters. The words are usually separated by white space or punctuation characters in the English language, and we will use this fact to process our text in the form of words, or as we shall later call them, tokens. So, as we mentioned tokens, let's look at the process of tokenization. Tokenization in NLP is the process of splitting a given sentence into words, which are called as tokens. And as we discussed in the previous slides, these tokens can be anything from words to phrases or even sentences, depending on your application. The tokens work as a fundamental unit to be processed in NLP. Therefore, in any NLP application, it is a very important step to create appropriate tokens. With this, it is time for a demo on tokenization. So let's jump into it and see how we actually tokenize the text. Alright, so here you can see a Google Colab notebook where I will be running my code. This is a Jupyter notebook like setup which is free for everyone, and I will be sharing this notebook with you all, and you can basically interact with it to run each line of code individually and see the output on the console. And we are going to use the popular NLTK library in Python for all our basic NLP tasks such as tokenization and text pre-processing. By the way, a fun fact, did you know that the full form of NLTK is Natural Language Toolkit? For knowing more such facts, subscribe to my channel ML Wiser to stay wiser. Okay, so let's start this. So we will look at different types of tokenization here, and in the first checkbox, as you can see, we have imported the NLTK library, and we have written our text, which is the fox jumped over the fence, didn't it? And we are going to look at three different types of tokenization on this text. So first is the whitespace tokenizer. After importing the whitespace tokenizer from the NLTK library and running on this, we can see that it splits the given sentence into different tokens on the whitespace character. But there are several issues with it. Can you see them? So the issues are that the it ? Token can be considered similar to it, just a word. So just like this, there is also the word didn't, which you can consider as did and not separately for a better efficiency in the tokenization. So to solve these issues, we will look at the few further tokenizers which we have listed here. So first is the word punctuation based tokenizer. So the word punctuation based tokenizer splits the text on the punctuation characters instead of the simple whitespace character. And after splitting on the punctuations, we can see that the it ? Token got separated into it and ? separately, which is nice. But we see another problem, that is the didn't got also separated as didn't and t, which is a problem. So to solve this, we will further look at another tokenizer which is called as a custom tree bank tokenizer. And in this tokenizer, it is a regex based tokenizer, so you can definitely check out the NLTK's official documentation for how it works. But at a high level, you can consider this as a better as a smart tokenizer which understands the text and it splits them appropriately. So after applying the tree bank word tokenizer, we can see that the didn't got separated into did and not. Also the it ? Token got separated into it and ? Which is nice since this is how we exactly wanted it. So these are the three different types of tokenizers which we saw, and you can use any one of them. But I will recommend use the tree bank tokenizer because it works on regex and it usually gives you a better list of tokens. Now that we know how to tokenize our text, it's time to learn about some text preprocessing methods to improve the quality of our tokens. And the first method is the stop word removal from the text, where we remove words like the, and, is, etc. from the input text, as these words don't add any extra meaning to our sentence, so they are better left out from the processing. Next is the stemming method, in which we remove the suffix from the word to get its root form called as stem. For example, the word wolves can be reduced to wolf, rocks to a rock, and the word ponies can be similarly reduced to just a pony. This process helps us in reducing redundant or unnecessary tokens to improve the efficiency. Finally, we have the lemmatization method, in which we return the base or dictionary meaning of the word from the given token, which is known as its lemma. If we apply lemmatization to our previous example, we get conversions like wolves to wolf, rocks to rock, and ponies to pony, which looks semantically more correct. You can apply either stemming or lemmatization or both in your application as a part of text preprocessing. With all these methods, it's time for another demo to see how we can achieve the same things in Python. So we are continuing in the same Jupyter notebook, and so here we will first load the NLTK library and the WordNet lemmatizer package. And for stemming, we are going to use the Porter stemmer, which is already included in the NLTK. Firstly, we have loaded input text, which may not make much sense right now, but we will be using this just to focus on the individual words in it. Next, we tokenize the whole sentence using the tree bank tokenizer, and the result, as you can see, is a simple tokenization, kind of where the words are remaining the same here. And after this, we will do the stemming and lemmatization. So for stemming, we create a Porter stemmer instance and apply stemming on each individual token to get our results. And we can see that the suffixes from each of the token are removed and the words are converted to their base form. For example, the wolves got converted to wolf, ponies got converted to pony, and rocks got converted to rock. Next, we are going to use the WordNet lemmatizer to lemmatize our text. So we will apply this method to basically lemmatize it, and we can clearly see the difference that the words like corpora got converted to corpus, wolves got converted to wolf, ponies got converted to pony, rocks got converted to rock. So these are semantically more correct words, and so this is all for the text preprocessing. Next, we will look at our feature extraction model. So here we will study a simple model called as a bag of words model, or BAW. As the name suggests, it is a literally just a bag of words where we randomly take the tokens and count their occurrences in the given text. So that's what we are going to do, and what we are looking for are marker words like good, bad, which define the sentiment, or you can say the meaning of the sentence. And for each token we will have a feature column. So let's look at 3 reviews. We have 3 reviews like good movie, a bad movie, and good acting. So these are just a simple reviews to just look at how we segregate them into different columns for our bag of words model. So when we separate them, we get this table where each word is a feature column, and we get a feature vector where we count the occurrence of each word in the given review. For example, good movie, 1 is populated in the word good and movie, and 0 is populated everywhere else. And in a bad movie, 1 is populated for these corresponding text or tokens, and 0 is filled everywhere else. Similarly for the good acting. So this was the simple bag of words model where we used single token as a feature for our feature vector, and we just count their occurrences in the given sentence. Next, we will look at the N-gram features. So if you observed in our previous slide, there are some cons in using this model. For example, the ordering is removed in the process when we consider each token as a separate feature. So ordering in NLP is very important, and the bag of word model loses it due to this simple processing. So to add a little bit of ordering to our model, we will introduce the N-gram features. So 1-gram model will be simply called as a token based model, 2-gram can be called as a bigrams, 3-grams are called as trigrams, etc. So if we look at the similar reviews, but now we will consider both 1-gram and 2-gram features, we get this table, whereas you can see the good movie is populated as a single one in the first row, a bad movie got populated in the movie, bad movie, and good acting will have its own token. So the N-gram features preserve the ordering, but they come with a flaw that you cannot have a lot of N-gram features. In a sense, if you have like 100-gram features, there will be a exponential rise in the number of combinations you can have, and it will really impact your efficiency in the model. So to prevent this, we generally use bigrams or trigrams in our general NLP tasks, and as we shall see how to use them in our application. Alright, so in this demo we will look at the feature extraction from text in our simple bag of words model. We will first look at the single token occurrences count, which we just saw in the previous slide, and I will also show you guys N-gram tokens with TF-IDF values. TF-IDF is a very common metric to replace the single occurrences count to improve the efficiency of our model. So the single token occurrences count model, we will construct it as follows. First we will import all the important libraries like NLTK, stopwords, wordnet, some other things, etc. And first we will review the stopwords from our input reviews. So we have 3 reviews here. The movie was good, I hated the movie, and the upcoming movies are okay. So as you can see, I have taken 3 examples here of a positive sentiment, a negative sentiment, and a neutral sentiment. So first we will just take a copy of this review and we will do some processing on it to basically apply the stopword removal process. And as you can see, after processing, the stopwords are removed. For example, the movie was good is now only the movie good. I hated the movie becomes hated movie. The upcoming movies are okay becomes upcoming movies okay. So semantically, these words might not have a meaning, but from our model's processing perspective, these are a better set of tokens. So I said tokens, but we haven't applied the tokenization yet. These are still strings. So we will apply the tree bank word tokenizer on this to get tokens for each of our review. So as you can see, it simply splitted them because they were simplistic words, so there was not much of a processing there. Next is the stemming and lemmatization. So I have imported the similar porter stemmer and the wordnet lemmatizer for this, and I have applied them on this reviews to get this tokens here. So you can either apply stemming or lemmatization or both. Here I have applied them in this order. So it might not make sense for some applications, but it might be useful for some others. So depending on your application, you can use either of these. And then we will select some distinct tokens out of these. So as you can see, some tokens like movie are repeated here. So we want to remove those. So we will take a set of those and we get this 5 tokens from all of our 3 reviews. Next we will import the pandas library, which is popular for its data frame usage. and a counter class to basically count the occurrences of tokens in our reviews. So first I will create a data frame with our reviews and the processed reviews. So the processed reviews were our tokenized reviews. So as you can see in the output below, this is the output we get after we count the occurrence of each token in these 5 individual tokens which we extracted. But this looks a bit messy. We don't know to which token does each of this 0 or 1 correspond. So we will do a bit of a processing on it, where we will map these counts to the distinct tokens which we extracted, and we get this data frame where it looks nice and tidy. We have the reviews, the processed reviews, and the count for each one. So this is our basic bag of words model for a 1 gram feature vector. Next we will look at the N-gram tokens with the TF-IDF values. So as you can see, again we have followed the same process, importing some important libraries and on. And here is an important function which I have constructed. So this function I am calling as text preprocessing tokenizer. So it does a lot of things. It removes the stop words from the given text, and it also lemmatizes and applies stemming to the given text as well as tokenize it. So it combines all of our text preprocessing steps in a single function, and we will be using this later into the TF-IDF instance which we'll be calling. So as TF-IDF is a complex concept in itself, I will not be explaining it in this video. If you guys want it, you can let me know in the comments if you want a separate video for it, and I will make it. But right now you can understand TF-IDF as a value which is basically high when the term frequency in the given when a term has high frequency in the given document and a low document frequency in the overall collection of the documents. So we are looking for those keywords which are present in a particular document rarely, which defines the sentiment or the meaning of a particular sentence. So for this example, I have taken 5 reviews. The movie was good, I hated the movie, and the upcoming movie is okay. Also movies was bad, and I like the movie. Next we apply the TF-IDF vectorizer class from the scikit-learn library. We define this instance. So it has the option of selecting a tokenizer. So we will be using our function as a tokenizer here. So we are calling it as a tokenizer, but it is really applying all the pre-processing which we are doing on the text here. Then there is the min-df feature argument which defines so min-df simply means min-df equal to 1 means that ignore the terms that appear in less than one document, and max-df equal to 0.8 means that ignore the terms that appear in more than 80% of the documents. So as you can guess, min-df equal to 1 simply means we are considering all the tokens, as this is a small example. But as your dataset grows, you can consider taking higher values of min-df as well as setting max-df accordingly, so that you can filter out the more frequently occurring tokens which may not be useful for your model. Next is the n-gram range argument, which takes in what n-grams you want to take. So when I set a range like 1 to 2, it takes 1 grams as well as 2 grams. If I set it to 1,1, it will give me only 1 grams. If I set it to 2,2, it will give me 2 grams, etc. And next is the stop words, where we remove the stop words from our text if there are any. And next we apply the fit transform method in this. Next we apply the fit transform method on the text we have to get the features, and we show them in a pandas data frame. So as you can see, we have a data frame here where each of the 5 reviews, for each of the 5 reviews we have a TF-IDF score. Somewhere we have scores like as high as 0.7, somewhere we have 0.5, but most of them are 0. So when we say 0.7, that means this particular words get a bigger advantage as compared to, let's say, a similar word which has a score of 0.5. So that's how TF-IDF identifies the important tokens in our sentence. So as you can see, there are both 1 grams and 2 grams present here. But let's say if I change this to 1,1, we shall only see 1 gram features, as you can see here. So somewhere we have scores like 1, and in some reviews we have scored like 0.7. So now if I change this to 2,2, we will get only bigrams, as you can see here. So just for fun, let's apply 3,3 and let's see what trigram shows us. So there is only one trigram it detected, which was this after removal of. So why do you think this happened? The reason is simple, because after removing all the stop words from this reviews, only this third review was left with more than 3 words, which was considered a trigram. Therefore we got this data frame here. So I hope you found this useful, and that is all for this video. So thank you, fellow wise ML folks, for watching this video till the very end. If you like the video, please give it a thumbs up, and to get more updates on such ML content, subscribe to my channel ML Wiser to stay wiser, and I will see you guys in the next one.